Okay, worked example 7.2c is one we did in class. I'm going to do it again. That flickering is the fluorescent light on that book. It doesn't flicker on this book. I do not know why. So here it is. We have got two wires and they are like this coming up out of the page. So they're like that. So just let me balance that. Righto, right hand rule, thumb in the direction of the current, up out of the page. Fingers round in the direction of the magnetic field. Right, and I can do the same thing over here with this other one, and its magnetic field is going this way. So I'm just going to turn the book upside down because it's just a little bit easier for a minute. So I'll use the same pen. Be consistent. Righto. Here, coming around in a circle at this point P here, the direction of the magnetic field at that infinitesimally small point is straight ahead, right? At a right angle to the radius, tangent. So there it is there. And I'll do the same thing with this other one, and I will get tangent to the circle here, straight down like this. Right, and these are at 90 degrees to each other. So then it's just a matter of working the problem. So if we look at the magnetic field of X at P, and it's got this stupid, it's my professional opinion, I on R. This thing is equal to 4 pi times 10 to the negative 7 on 2 pi. Why on earth would you ever write it? Why would you never just write it as 2 by 10 to the negative 7? Right, times I for xi was 8 and the radius is 0.2 because we've got to work in meters. And we end up with 8 by 10 to the negative 6. Right? 8 by 10 to the negative 6 Teslas because it's magnetic field. And here it is here. It's going straight ahead along that line towards Y. Alright, so then we do the other one. Exactly the same. Only I'm already fed up with that stupid constant business, and I'm just going to go 2 by 10 to the minus 7 times I over R, which is going to be, and this one had a current of 6, the radius is still 0.2, and that becomes 6 by 10 to the negative 6 Teslas, and that's coming along this one. So if we were to draw a vector diagram, then we would have wait on, I'm gonna have to try and, I don't know why it's not doing that properly. I don't know. 8 by 10 8 by 10 to the negative 6 this way, add on 6 by 10 to the negative 6 that way, and we've got a right angle there, so we're looking for, that's awful, why is it doing that? Hey, it's called technical difficulties. Righto, so we can work out this using Pythagoras, and it will come to 1 by 10 to the minus 5 Teslas. So that's just c squared equals a squared plus b squared. So you can work that out, no worries at all. Now, According to your textbook, this angle here is 45 degrees, and I assume that is due to some kind of geometry to do with this isosceles triangle. There's no explanation for it. It's beyond me, mathy. You'll have to ask someone good at maths why they think it's that. So use tan to find theta, and then they actually use this angle here, which they label as phi. And this one in here ends up being 36.9. So this one out here is 8.1. And they can say then that that is 8.1 degrees to this line here, the line between the two. If somebody can work out why that's 45 and tell us, that would be awesome. Some kind of geometry involved, I imagine. And maybe they used that 28.3 in that geometry because it hasn't been used for anything else. But anyway, if you can work that out and let us know, that would be great. Thank you.